Welcome to Nelson Learning Space. So today I'll be teaching you guys capacitor. Capacitor is kind of easy. You just need to understand the right formula to use and how to navigate around it. Funny enough, UTME like asking questions under it, especially under energy stored and electric field intensity. So today I think I'll be able to solve two UTME style questions and even take one from past question. That's a 2016 question number I think 5 or 15, I can't remember again. So, well, not much talk. Let's just get right into it. The question on the board says a 4 microfarad capacitor is connected to a 12-volt battery. Find A, the charge stored, that's in the capacitor. B, the energy stored, same in the capacitor. Now, the first step in solving a question like this is bringing out the given parameters. So we have the given parameters. And what are the given parameters? Which is we have this, and that's capacitance, which is equals to 4 microfarads. And that's also equals to 4 times 10 raised to the power minus 6 farads. And then we have this voltage V, which is equals to 12 volts. And then if we're looking for what we're looking for, we have the charge stored. And what is the charge stored? That is a Q. Is unknown or is missing. And what is the formula? The right formula to use is what? CV. And then we have this, the energy stored. What's the energy stored? E. Is also missing. And what's the formula? Formula is half CV square. We're done. Tada! I think if you get the formula and you get the parameters, we can solve then. So let's solve. Let's solve the first one. First one, which is Q, once again, is equals to what? CV. What's our C? Our C is 4 times 10 raised to the power minus 6. There was V, 12. Multiply by 12. And then let's bring it together. That will be equals to what? That's 48 times 10 raised to the power minus 6. The answer can be this, which is column, or can be this. 48 microcoulombs. Whichever one you leave it is correct. Tada! We're done with A. Now let's try B, which is this. But I have to rub off the board. A moment, please. Okay, we're back. Then B, the energy stored. And we say the energy stored is equal to what? Half CV squared. That's half multiplied by, what's our C? 4 times 10 raised to the power minus 6. What's our V? 12. That's 12 squared. And that is equals to half multiplied by 4 times 10 raised to the power minus 6 multiplied by 144. Now let's bring it all together. Let's solve. That's 4 times 144. That's 576 times half. That's 288. So that will be equals to 288 times 10 raised to the power minus 6. You can either leave it here as joules or equals to 288 millijoules. We're done with number 1. Don't forget the formula. Q is equals to CV, while energy stored, which is E, is equals to half CV squared. So let's try number 2. So number 2 goes like this. If the voltage applied across the plate of a parallel plate capacitor separated by a distance of 0.02 meter is 5 volts, find the magnitude of the electric field intensity in the capacitor. Ignore the fact that the question appears to be long or whatever. It's simple. So first step, like we always say, is to what? Bring out your given parameters. Most especially for those students who are in exams that involve theory. Your workings also give mark. So try to always do that also. Given parameters, we have I think here we have we have distance, which is 0.02 meter. Then we have 5 volts, which is voltage, and voltage is what? 5 volts. Then the electric field intensity that we're looking for, E, which is missing. And what's the formula? Very simple formula, V over D. Tada, simple. Now let's solve. So since E is equals to V over D, we can say what's our V? 5. And what's our D? Our D is 0.02. And that will give us what? 250. And what's the unit? Volt per meter. That's the final answer. Tada! You're done. Now it's your turn. Try this. Now try this and drop your answer, if possible, your workings in the comment section. If you find this helpful, kindly like, share, and subscribe so you don't miss the next breakdown. Cheers! Once again, welcome to Nelson Learning Space.